So just to summarize what we discussed in our last meeting, were essentially what do we have to do to move forward with the current proposal for pod level checkpoint restore. And Peter was very helpful. He had a lot of feedback on what would be the best way to move forward. But the main essentially blocker that we currently have is how to what happens after we restore a pod in Kubernetes. Because what we can do in at kubelet level is we can the container runtime can create the pod sandbox, and it can also restore the containers. But we in the current proposal we don't have a way of telling the API server to tell Kubernetes that this pod has been restored and it exists. So essentially, Peter suggested to figure out how to essentially what is the minimal changes that we can essentially propose to the API's SIG to the SIG machinery, essentially to be able to have an interface that allows us to essentially restore pods. And I've been trying to figure out what is the best way of doing that. Like we have discussed this in the past several times, and essentially what we want to do is we don't want to create another cap, but we want to extend the essentially the scope of the current cap with essentially with the necessary changes that allow us to have functional implementation. I'll try to share my screen just to. So I created a draft of essentially proposal that described something that we can propose to the essentially to SIG API machinery, and I just want to get some feedback on whether this is essentially the thing that we want to propose, or if anyone has any comments. Essentially, my plan is once we kind of agree on what the next step will be, I can, for example, go ahead and propose this to and discuss this with other people in different SIGs. Dan, I see you have your hand.
Yeah, can you share that link for that document?
It should be in the meeting notes.
Oh, thank you.
So it should be this link here. But so essentially, it's very how to say it's very straightforward. Like there is nothing really complicated in the proposal. So essentially, we have an interface called checkpoint and an interface called restore, and these are essentially sub resources for pods. So it's kind of checkpoint is very similar to how I guess you would terminate a pod, and then the restore is very similar to how you would create a pod. At least this is what I'm using as guidelines. And in terms of requests, we have like a essentially just a set of options. In this case, is containers that we want to restore and timeout in terms of seconds for both checkpoint and restore operations. And yeah, my plan is to kind of create a proof of concept or something that we can essentially show to essentially something that would allow us to get feedback. But the main idea is that these APIs would essentially trigger the kubelet API, which will essentially code the use the CRI interfaces to code the container runtime. And essentially, when this functionality is enabled, the API server will have the pod, the checkpoint and restore sub resources, and when it is disabled, these APIs will not be available. And one thing that we discussed in the previous meetings was we want to reduce the scope of the proposal so that essentially we can it's essentially something that will be approved. We don't have to go through too many discussions, but essentially my understanding is that if we are introducing restore API, we should probably introduce the checkpoint API as well. So this is why I've included both. I'm not sure if there is a better way of doing that, but this seems to be the most straightforward approach. And I want to ask, I'm not sure if Peter has any comments or suggestions on what is the best way to move forward with this.
Yeah, I mean, I think at this point we need to get feedback from. I mean, I can definitely take a deeper look and make sure we feel ready about it. But if we have consensus in this working group about it, then we just bring it to the ASIC API machinery.
Yeah, I was looking at the next meeting. I think it's next week or the week after. But yeah, this is fine. And I see Tim. We have any comments or suggestions?
Yeah. So with the restore API you're proposing here, is that saying it would just restore to the same pod that was checkpointed?
So I think we sort of discussed this I think previously as well. So the idea is that we want to create a new pod, because essentially if we try to restore the same unique ID, pod ID, this will be very difficult. So I think what you suggested previously is the best approach forward. So essentially when we restore a pod, we create a new pod that is using this checkpoint. And it's also applicable when we want to use the same checkpoint multiple times. So we can restore multiple pods from a single snapshot, single checkpoint. Did that answer your question? Yeah.
Yes. So you're saying you would create the pod first and then restore the kind of like overwrite that pod with the checkpoint? Is that?
So the way I see this is very similar to how we would restore essentially using container checkpoints today. So what we do is we essentially create a copy of the YAML file, of the pod YAML file, and then we just change the image for the container to point to a checkpoint image, and then we create a new pod using the checkpointed containers. So the way I see this is kind of very similar functionality, but it's Kubernetes native. It's part of Kubernetes.
Okay.
And I think Adrian also he knows a lot about. He also tried to write a KEP in the past about the API, how to extend the API server. And I just want to check if Adrian has any comments.
No, not really. It's I'm not up to date about this approach yet. I missed a couple of things. I'm confused why there's a restore before the container is before the pod is restored. But I need to read up what this is. I didn't have a chance, so.
Yeah, so essentially it's very similar to what we kind of proposed in the past. If you remember when you opened the pull request for the kubectl checkpoint command. So the main difference is that in the KEP that you wrote initially, we had only the checkpoint functionality, pod checkpoint. And here we essentially, for us to move forward with the current proposal, we need to essentially define how restore is going to work. Essentially, this is the main feedback that we have, because we can do the restore at kubelet level, but we need to figure out how Kubernetes will know that this pod exists. Essentially.
Yeah. So this API says pods and then name and restore, but the name doesn't exist before the restore, or is there does the object already exist before you call restore?
So the idea is to be something similar to how we create pods. So I'll double check here and get back to you on how it works. But
okay, I don't know how create works, but if create works the same way, then it makes sense. Yes, of course.
Yeah, this is what I'm trying to do. Yeah. Philippa, I see that you're adding comments. Do you want to discuss them?
I'm just curious because from the point of view of a user, like um, imagine that you are a cloud provider, for example, you already have all the admissions, webhooks, or you're a customer that is going to use this like a consumer. I don't, the same webhooks that you have for admission and validation for create, because the restoration is basically a create call, right?
Yeah.
What would be the approach here? Because this is very important, in my opinion.
Can you just repeat the question? I'm not sure if I understood that.
How are we going to deal with the validation webhooks and because restore is basically a create pod, but the only thing that changes is exactly the state that's different, right? So have you thought about that?
So the main, essentially, the main difference is essentially the containers. So we are restoring the containers from essentially from the container runtime. So I don't think there is like significant difference between creating a pod and restoring a pod in terms of validation. I would just see the implementation, how it works with create, and then I will try to essentially figure out if there is any challenges there. But I don't. Today it works with create, right? We can just create a copy of the pod YAML file, and then Peter, I see you have your hand.
I see Felipe's point though, which is that the admission webhooks only act on a certain sub-resource of things. So if it's only watching, or it has to opt into sub-resources that it acts on. So if it's watching for a create and then a restore comes in, it might not actually mutate the pod restore in the same way that it did the pod creation, and that might subvert admin expectation. So I wonder if there's a way that we could, in API machinery, treat a restore similarly to a create in that situation where any admission webhook that acts on a create would also just transparently act on a restore.
Yeah, I think this is a very good question. I can ask during the meeting when we discuss with this API machinery, and I think they will probably know better than I do what is the best way of doing that. Whether we should use essentially what we currently have, like a separate restore sub-resource, or somehow modify the create sub-resource to also support restoring. But yeah, I think just asking them for feedback might be a good question. But yeah, I think this is pretty much everything in terms of next steps. Essentially, everything else in terms of like handling of volumes, handling of dynamic resource allocation, and other things we currently keep out of scope because essentially it's something that we can handle in a separate enhancement proposal. I'm just reading through the comments. I think this is pretty much everything. A lot more details in terms of error handling, like what are the different types of errors that we want to return. For example, when the functionality is not available, when we run out of resources, and things like that. But this is more like details that, Peter, do you have any suggestion or advice on how to essentially integrate this with the current enhancement proposal?
I think eventually this will become a stage of the existing enhancement proposal. So I think we would expand the scope of the enhancement proposal to include API-driven checkpoint and restore. And maybe the initial stage would just be like drafting out the API and getting the CRI API pieces in place or something like that. But this would be like the eventual goal of it. I don't think we can separate this from the Cuba pieces because of the restore question.
Yeah, makes sense. And Dan?
Yeah. So just to be clear, the API is not supposed to talk about how we're going to handle stuff like I don't know, secrets, or I don't know, anything of the implementation wacky stuff we talked about with the SIG guys, and which got us to like push this to 1.37 because it's so complicated. So this is not part of this API suggestion, right?
So essentially what we're trying to, so the current enhancement proposal in the current state, it has checkpoint and restore functionality at CRI level, kubelet level. The problem is once we restore a pod, we don't know what to do with the pod. So essentially we don't have a way of telling Kubernetes that this pod exists. And this is why we are trying to integrate essentially an extension of the API server within the existing enhancement proposal so that we can answer this question. Is that what you were referring to?
Yes.
Yeah, so essentially we discussed this with Peter a few times, but essentially this is the best path forward. So we don't want to expand the scope significantly, but we need to answer this question to be able to show how users are going to use the restore functionality. Philip, do you have your hand?
Another question, like I don't see any mention of status. Are you guys going to discuss the status or the state machine of the pod with other groups? What is the consensus?
Yeah, I mean, to be honest, I think we have to essentially discuss this, but I think it's not the SIG API machinery, probably. It's maybe SIG architecture. Maybe Peter would have better suggestion who is the right person to talk about states.
I mean, I think for the pod state machine, it would be Node.
Okay.
Yeah, so I think basically I think the approach that we should take in this KEP is expand the scope and answer more questions from the beginning. So I think we still have a lot of the open questions from the initial scope of it, like the state machine piece, like, how are we going to exclude secrets and your volumes and things like that. But then there's also new open questions about what the structure of the API looks like, because the initial KEP wasn't sufficient to sort of, cover our bases there.
Yeah. And in terms of essentially adding additional states will be useful in terms of integrating with other components in Kubernetes, but we have to make sure that we achieve consensus whether checkpointing and checkpointed would make sense to be added. But yeah, I mean, we have to discuss this with SIG-Node, as Peter mentioned. And I see one question in the document. What is going to be preserved across checkpoint and restore? So, well, the runtime state. So essentially, the main thing that we want to preserve is when you restore the pod, you want the containers to resume from the point in time when they were checkpointed. This is the main thing. What we have been looking at is to preserve the annotations, metadata, and pretty much create almost identical copy of the pod, with the main difference being is that the unique ID should be different. And if, for example, if there are, I think if there are resource requests, they should be the same. I don't think we can handle at this point resizing the pods or anything like that. But we can just, once we have a proof of concept, we can demonstrate what is possible, what is not possible, and then we can essentially answer this question in a better way. Yeah, Tim.
Yeah, I think that's a really important question to kind of answer really precisely, because that is going to have a lot of implications for the use cases, and that will be important for understanding if the solution works, right? Yeah.
So we currently have identified several main use cases. One of the most popular ones, I think, is accelerating the startup time of, for example, inference functions. Like, for example, if you create a snapshot of VLLM, you can essentially resume from this snapshot within seconds rather than a few minutes to initialize the model. So this is very popular use case where snapshotting is important. Another one is where, so for this use case, we want to be able to handle GPU state, but also to create multiple pods from a single snapshot. So it's kind of similar to a serverless use case where when a user sends a request, you want to start the application as fast as possible. So this is the main use case here, and I think this is what I have in mind when I'm like thinking about the state that we want to preserve. The other one is when we have essentially long running application. Like, for example, we have HPC simulation that is running for several days or weeks, and it has to be preempted, or essentially the pod has to be terminated. In this case, we use the checkpointing mechanism as fault tolerance. So if the pod is terminated, we can restore from the last checkpoint. Here, we want to be able to essentially reduce the amount of time where the pod is in a frozen state, but so that we can, the performance overhead of checkpointing is not very high. But in terms of preserving the state across checkpoint and restore, we want to be as identical as possible. So in this case, again, we can use different unique IDs after restore. But yeah, essentially being able to say this is the application that is that has been restored is important. Yeah, I mean, I'll try to answer this question in the CAP in more details. As you said, it's important. But I hope I was able to provide an answer here as well.
Yeah, I guess just to riff on that a little bit, I think we definitely want to be very precise about what is being preserved, just because I think that sort of will inform all of our future design as well. So
yeah, makes sense. And thanks for the question. Vicky, I want to ask you also, I know we worked in the past with Jupyter notebooks. So for example, when we have users that have a Jupyter notebook that is currently running, but you can see from the CPU and GPU utilization that they're not actually using it, and you can essentially use the checkpointing mechanism to stop this Jupyter notebook and then to resume it later. If with this use case in mind, do you think the current checkpoint restore APIs would be useful? What do you think?
Yeah, I think they would be useful. I don't see any like immediate problems with the design or anything that should be added. We already tested the checkpoint with existing curl command, and it worked as it is now. I am quite sure that the timeout field will be necessary, but I see that that is included in the pod checkpoint options. And for the restore, I think the options that are currently listed would be also enough, because this use case is not very complicated. It is quite simple. So I think this would work, and we could even like test it once there is some prototype implementation with exactly this use case, and see if there is some immediate problem that would need some fixing.
Yeah, makes sense. And And I see that David is also on the call. David, do you know if this is kind of similar to what is currently used in GKE, like in the Google Kubernetes Engine? But would it make sense to have essentially checkpoint and restore sub-resource for the API server? Or from the documentation, what I know is that you guys use CRDs to create snapshots and to essentially use annotation to restore pods from snapshots. But I just want to ask for any feedback or advice you may have.
Yeah. Sorry, I joined a little bit late, so maybe I didn't see the earlier part of the proposal. But in general, I think maybe what would make sense, would be my suggestion, actually, maybe it's a little bit different to the proposal here, is for us to maybe start by focusing at the CRI layer before we kind of get to the Kubernetes API and kind of really standardize the CRI interface and so forth, and maybe make it in such a way that it's kind of pluggable. So I could totally see a world where maybe GKE has their own checkpoint restore CRD, and maybe we have an open source implementation and maybe a CRU specific implementation or something like that. And so but we standardize at the CRI layer, right? And so that allows people to kind of be very flexible in terms of the APIs and what fields they want to have and maybe the storage mechanism and so forth before we introduce it in core Kubernetes, right? And then maybe once we get actually some different implementations, like maybe there's a GKE implementation, a CRU one, et cetera, right? Then we can kind of come back and then have the API discussion. I just feel like if we kind of try to have both the runtime discussion and the API discussion and have it all at once, it's kind of a lot to get in at once, right? So maybe some sort of a phased approach may help to kind of be able to make progress here.
Yeah, and I just want to share with you. So this is the gap that we currently have, and essentially the main challenge with this gap to get it approved and merged is so in the gap we have a checkpoint and restore pod CRI APIs. So essentially what you suggested exactly to define the checkpoint and restore functionality at CRI level. The main problem is when we restore a pod using this CRI API at kubelet level, we don't have a way of telling Kubernetes that this pod exists, that this pod has been restored. So this is the reason, essentially, we discussed this in the previous meetings, that we have to extend the enhancement proposal to essentially define an interface in the API server that would allow us to be able to restore pods. And essentially, this is the reason I created this document. I agree with you.
Yeah, maybe one option there, and I think Peng-John's on the call. We were talking about this offline, and maybe we can share kind of a short idea what we had. But maybe there's a possibility to have this as a plugin, right? So without being in the API service, but basically kind of think about it like a plugin that maybe either the container runtime or kubelet calls during restore to validate, should this pod be restored or should it be a fresh pod? And maybe from the Kubernetes perspective, we can kind of just treat it like a brand new pod. For now, right? And then maybe over time we can kind of converge and have dedicated implementation. That was one thought. Maybe we can share kind of some ideas there in follow-up meeting and write it up.
Yeah, I think the big open question that we have is with that approach, which I was hoping to do in the 136 cycle, but then there's the question of okay, so the kubelet gets told to restore this pod, it plumbs that down to the CRI restores it, and then the kubelet has this new pod. How does an end user query the pod status of that pod? Is the kubelet telling the API server hey, I have a new pod? Is it the entity that's doing that? Is it being treated like a mirror pod? I guess it's the problem about going that approach is we lose some of the benefits of having a restore specific API, while also sort of we would need to have some interim hacks to sort of handle.
Yeah, makes sense. Well, I think this goes back to the point of do we want to target actually making checkpoint and restore part of the native Kubernetes API? And if the answer is yes, then makes sense for us to do that. But if the answer is no for now and we want to do it just to the runtime layer, right? I think maybe you could delegate that problem more to whoever's implementing this, right? For example, they could create a dedicated CR, or they could maybe annotate the pod or add some type of event, or they can find some other mechanism to describe this in the Kubernetes API for now, right? Before this is fully standardized.
I guess my feeling is eventually we will. I do want there to be native API awareness because I also want like higher level objects to be able to know that a pod that it controls is being checkpointed and restored. And because of that, I think like we should do it the correct way first, even if it's a larger piece of work, so that we don't have like interim hacks that sort of like muddy the implementation process.
Makes sense. I just think like I agree with you. Like long term, all I'm trying to think is like to standardize kind of API that works across all the use cases is quite challenging, right? And maybe we don't have all of the details there yet, right? So being able to make a little bit of progress on CRI and then kind of figuring out and seeing how different people implement it may help us get the signal, right? What should actually be included in the native API. Because it's hard to say kind of until you see different implementations. So I totally agree. I think that makes sense. That's the long-term direction.
Yeah, I'll just follow up on that before I go to Philip. What we were trying to do is create the generic options field so that we can so we define the minimal set of fields that we need, like path for the location where the snapshot will be, the snapshot that will be used, config for the pod configuration, timeout for the restore operation, and we have like a flexible map field that can be extended in like within the implementation itself. And then it's just container configs. So this is essentially what we currently have as the restore CRI API. And I think this is probably the best we can do at the moment. And so, for example, Gvisor, Creo, they can have different options, but essentially this field should be able to support different implementations. Philip, do you want to go next?
No, I just want to comment that like we already have a lot of workarounds and things working on CRI level. Is not something that we're going to throw away. Like I think Adrian is working on this initiative like in the past 5 years at minimum. The main point of having this in high level, I think, I don't know if I'm talking basically on the comments of David, is a lot of use cases that we have nowadays. For checkpoint and restore, they rely a lot on scheduling. Like so, we want to be able to have superpowers in Kubernetes and allow schedulers like Queue or whatever to do like some magic with pods, and this is not possible nowadays. So having the API high level in this case will help a lot because you can seamless integrate in the Kubernetes ecosystem itself without hacking because there's too much hacking going on right now. So we need a clean way to do it. I think a lot of people or a lot of companies are doing it, but it is not fun. You have to do too much stuff that shouldn't be done. And I think this mainly solve it. And so, yeah, that's the main goal, I believe.
And quick question there, Felipe, just to follow up. Can you expand a little bit on the Queue use case? Like, how does the API, in your perspective, help with Queue integration?
Yeah, because Queue right now, I don't know if you know or a little bit that I know. Queue works with the job preemption API, so Queue can just preempt the job calling the controller, like the specific API. In this case, this could be native to the job API that you could pass a parameter saying that you want to checkpoint instead. So it is already hooked. So you can just call a native API directly, and you have that option of immediately checkpoint the workload instead of having an outside controller to do it. So bring these things inside Kubernetes instead of having everybody building your own thing. I know that's good, but at a certain point, I would love to see this as default. And I think that's the initiative.
I think long term that makes sense. The only question I have, which honestly I don't know if we've discussed or proposed here, right? But if we're talking more about like job level checkpointing, right? We need to solve somehow how to do the kind of orchestration, right, around synchronizing the checkpoint. And you know, a lot of the discussion here is based around pod level, right? Which maybe works for pods, right? But depending on what job you're running, maybe it does need to be synchronized checkpoint, maybe it doesn't, right? which is like another big can of worms to open, right? So depending what requirements we want to have for a job level checkpointing, right? We may have to change how the API works in some sense, right?
Well, I think that
Yeah,
we're sort of balancing the two different perspectives of like, let's not boil the ocean, but also let's do enough to be materially useful. So like, yes, eventually we'll need to figure out the checkpoint moving problem. And we'll need to, there's a bunch of stuff we have to figure out. We have to figure out like, RBAC. We have to figure out like permissions and stuff like that, encryption. But all of these things are definitely something that I want to get to. But my question in trying to work on this KEP, what is the minimum set of things that we can do that would not require us to backtrack, but would give us something materially useful? And to me, a pod level, like a API aware checkpoint and restore gives us that, where we're not hacking something in the CRI to the point where like we'll have to like basically tell a job controller to do something totally different in 2 years. But we're also not like taking on everything. We can extend it in the future, but we can also like, have something to iterate on. And that's kind of why we landed here specifically. But I mean, your points are totally valid in that like there are, to make it actually fully useful and actually like fulfill the vision that we have for this project, it will need to be a lot more. But, as you said yourself, like it'll be easier to iterate if it's smaller, and that's where we're at now. So I think that this is sort of the sweet spot of like, we're covering as many bases as we can to not need to like undo something, but also we're not like overcommitting to begin with.
Makes sense. I guess all I'm trying to say, like this pod level proposal, I think maybe makes sense in context of pod, but I'm not 100% sure, honestly, it solves the problem of multi-job level checkpoint restore, which may need kind of a higher level API, right? And then maybe application synchronization or something.
I mean, my vision is like this sub-resource is applied to all of these different controllers. So like the job controller also has a checkpoint restore sub-resource, and like the job controller can decide like, oh, this job is this is something that's running in CRUN or whatever, like I want to use CRY-U to checkpoint it. Or like, even if you're using something like PyTorch, or like the PyTorch controller can decide like, oh, like I want to do it with my special PyTorch checkpointing restoring. So like eventually, like this is step number one in a long process of like getting ecosystem integration. But I think we need step number one to get to that ecosystem integration.
I see. Okay. It might be worth then, maybe, I don't know if we've chatted with like the SIG apps folks and those folks, right? To see like if that's the plan, right? Like if we'll get their feedback kind of in some sense, right? Around adding this sub resource, right? Because it sounds like the proposal here is not just to add it to pod, but actually add it more broader, right?
Yeah, I think like in the process of talking through it, I think we're beginning with API machinery just to be like, hey, is sub resource the right thing to do? Or should we do a totally new API? Like, I think that's the 0th step. And then we'll go to other SIGs and be like, hey, like we're also thinking about this for other resources other than pods. What do you think? And so on.
Makes sense. Yeah, would be good to get feedback then from like the, PyTorch controller folks or whatever, and also maybe the job folks and so forth, right? Because there's, I don't know, like if we want to extend it per resource, I think there's definitely some interesting questions there, right? Because like even for job, we have jobs, we have how that integrates with Q, etc. Right? Like it's not clear to me that all works the same way.
Yeah, so the way we can do this in the future is it's a mechanism called coordination. So when you have distributed or multi-node or distributed workload, you need to coordinate the checkpointing and the restore mechanism. So in CRY-U, we have essentially a tool called CRY-U Coordinator that can be used to do that. But this is the main mechanism. So you have to synchronize the checkpoint and restore operation. And this happens usually at low level. It's not at Kubernetes level we can get the dependencies, what needs to be synchronized, but the actual synchronization happens later.
Gotcha.
I hope. Yeah. Tim, I think
kind of my question, right? Like if we plan to use some of the central kind of coordinator, then how does that integrate with this API, right? Or does it integrate naturally, I guess, right? Or do we actually need to extend how this API works? to support
it
that?
has to be the container runtime. So essentially, the container runtime will trigger the. Essentially, you need something additional so it's not going to be the coordination itself will be implementation specific. So you need something for gvisor, you need something for CRI-O, but this will be a separate thing. It's not part of Kubernetes. At Kubernetes, we can get a dependency. We can list of pods, for example, containers that depend on each other, and then we can define the API that will be used to communicate with the coordinator. I think this is probably what we're going to do.
Gotcha. But do we see that API being part of this proposal, or is that something completely the
No. It's essentially the same thing as Peter said. We first want to focus on something minimal, like individual pods, individual, essentially the minimal proposal, and then later on we can extend it. But we keep in mind that distributed and multi-node workloads is one of the use cases.
Makes sense. Yeah, but I think it makes sense. I think maybe it would be useful just like to understand a little bit how those two things like play together, right? Like if we have this pod level sub resource, how that would interact with the coordinator kind of flow, right?
Yeah.
Maybe that would be useful to kind of at least sketch out to see that the API helps address that as well.
Yeah, and Tim, I see that you have your hand.
Yeah, just to kind of follow up to David's point. I agree that we don't want to boil the ocean with the first implementation, that it makes sense to scope things down. But also, I think it's important to kind of think about and have some idea or sense of what the design would look like for some of these higher level questions. So we don't necessarily need to hash out all of the details and get like the design approved. But I think it's important that we have some idea of what the path forward might look like to make sure that we're not kind of designing ourselves into a corner by focusing on the wrong subproblem or something like that. Does that make sense?
Yeah, it makes sense.
Yeah, big plus one, I think, to Tim's point, and that's kind of why I'm bringing up, like, if this pod level sub resource helps us with the coordinated checkpoint and with like, synchronizing checkpoints across different nodes and so forth, right? Because if we want to introduce kind of standard API, we want to make sure we can extend it for those other use cases. I think that's kind of the question, right?
Yeah, I guess
the nice thing about CRI is like there's no API. I mean, there's pros and cons there, right? It doesn't fully standardize it, but at least it's standardized at the runtime, so we kind of punt some of those problems for now, right? But yeah.
I'm kind of jumping the queue a little bit with this, but one thing I was thinking about is whether there's enough overlap between suspend and resume with checkpoint and restore that it could be worth focusing on suspend and resume as a like kind of intermediate step, because I think if we treat suspend and resume as a kind of in place checkpoint restore, then it simplifies the pod lifecycle quite a bit, and we don't have to worry so much about like the notion of like recreating a pod and all the other resources around it, and kind of focus in on the like single node, single pod problem, and kind of get the CRI workflow right around that.
I agree with you, Tim. The main challenge with this is it will limit the use cases that we can essentially support, because for example, the use case where we create a single pod and restore multiple checkpoints, we create a single checkpoint and restore multiple pods from it. It doesn't fit very well with the suspend resume limitation.
Yeah, I mean, I'm not saying that like we do suspend and resume instead of checkpoint restore. I'm suggesting it as a like I think suspend and resume is useful on its own and is a simpler problem. And if we solve suspend and resume, it might then be easier to sort of generalize that to solving the more broadly useful and more complex checkpoint restore use cases. Does that make sense?
Yeah, Yeah, I agree with you. We have been working with Andrei actually on this. Essentially, essentially using the checkpoint restore functionality with the suspend field for job sets. But yeah, I agree with you.
I'm curious actually to go off that point. Like, if we wanted to adapt this API here, right, that sub resource checkpoint restore, does that help us with the suspend resume flow, or would it need a different sub resource API where we see this as like a status on the pod?
No, I think what we want to do is to create a generic checkpoint restore API that can be used with suspend resume as well. I think essentially there's no difference between when you suspend a pod, instead of terminating the pod, you can create a checkpoint. So we just need to figure out how to invoke the checkpointing functionality.
Makes sense. I guess maybe my question, maybe it's a question actually for Tim. When you were suggesting suspend resume, were you thinking that this becomes a new pod object, or we reuse the actual pod object and somehow that's like a status of whether it's suspended or not?
Yeah, I was proposing for suspend and resume. I was thinking we literally keep the same pod and change its phase to suspended or something. And so it just kind of sits there. We could even do something of like, it takes 0 resources, and then resume would include an allocation step where the kubelet has to reallocate resources for the pod, and we can reuse a lot of the in-place resize
interesting
flow for that. And so it simplifies the whole life cycle around creating the pod and figuring out the identity and everything to just a matter of kind of restoring this runtime piece. And then
interesting,
at the CRI layer, it might literally be the same. Even if it's a totally different API at the Kubernetes layer, it might be the same API at the CRI layer.
Yeah, that'd be interesting to explore how to support that, because I think that's pretty common use cases. The only thing like that, I mean, I don't really have an answer, but more of a question. But like for that type of flow, if we keep the same pod object, how do we deal with moving this across nodes, right? Because once you have a pod, it's kind of bound to a node. And I could totally imagine you want to suspend or resume across nodes. Or maybe you don't. Maybe that's actually a different use case on top, right?
Yeah. So again, I think like just the suspend resume on a single node, like, is the kind of feels like a simpler problem. And then if we can solve that, then we can start to think about, okay, what does it mean to
interesting, yeah.
So transfer to a different node or multiple pods.
Yeah, you're saying starting there as kind of like baby steps and kind of going from there.
Yeah, exactly.
Gotcha. Yeah, that makes sense.
I just want to check with Pengzan. I think you had your hand at some point. Do you have a question or?
Yeah, I mean, just some comments regarding David and Tim's discussion. That's actually like a high impact of what we are trying to propose. What we want to keep the pod or not, or like let's say if we just introduce the checkpoint. Let's talk about only restore. If we introduce the restore as a totally new code flow as a current like a sync pod of the pod creation, container creation. I mean, in that case, coordinator such as like a high level abstract like a job set, daemon set deployment controllers. I mean, this takes more work to adapt. Other than the pod object has been deleted, they just need to create the pod with some restore, like a metadata, like to indicate that this pod should be restored from some cases.
Yeah, I think it makes sense. It's when discussing with the SIG API machinery, we can probably discuss also these use cases. Essentially, for example, if we want to suspend a job set, what would be the best way to checkpoint multiple pods and to restore multiple pods at the same time? Well, in terms of API, what is the best API of doing that? I think this is something we can essentially discuss with them and figure out what is the best way of implementing this. Um, uh, Abhishek, sorry,
Hey,
missed
yeah,
you.
Abhishek. Yeah, you got it.
Okay.
I think I left a note in the doc as well, but basically,
Yeah.
would be good to understand whether we want to go with like a declarative style API here for checkpoint restore at a high level. In my mind, it seems like that's one of the key decisions we need to make for this SCEP, and maybe that's a thing to bring up with API machinery folks and discuss with them whether we want to keep it imperative the way it's designed today. So probably good to have a section in the doc where we kind of compare the two. In my mind, I feel like users would really like to understand the status of checkpointing. It can take a long time. It can get stuck in different odd scenarios. And so being able to have a declarative style API where we can actually see the status and monitor that versus imperative would be nicer. So
Yeah, I think this is a very good point. Like, for example, I know with GPU workloads, it can take like several minutes to
right.
create a snapshot. Like, and if you want to be able to see, for example, how in terms of percentage, in terms of progress, how what is the current progress of the checkpoint operation? Yeah, I think this is a good point. Like, I mean, it has to come from the runtime, right? We have to propagate this from the runtime back to the I guess Kubernetes level somehow, but yeah, I think this is a very good point. Thank you.
Thanks.
Vicky, I saw that you had your hand. Do you want to ask something?
Yeah, I have a question on Tim and David. So were you suggesting actually to keep the pod object in place, do not remove it and just restore back to it, while maybe even like downsizing the resources to sort of suggest that the pod is not consuming anything? Or did I miss something? Because it felt like you are suggesting to not create a new pod object for the restore, but keep the checkpoint one.
Yeah, that's what I was proposing for the like suspend resume subproblem.
Yeah, I mean, I think that how I see it, and Tim, correct me if I'm wrong, because I'm kind of building up your idea here. Like, you're suggesting kind of like there's different use cases here, right? But the most kind of simple is like you have a pod running on a node and you want to suspend or resume it on that node, right? For example, if you have an idle app or something like that. So starting there may be a good way to introduce some of these APIs and concepts, right? And then you can kind of imagine expanding it to, okay, now you want to suspend or resume across nodes, and then maybe across multiple pod replicas, right? Like for jobs or something like that. So it could be kind of an iterative process.
Yeah.
Can you imagine that if we like kept this design, we could modify like a node, because there is node name and everything? I guess that it would have to go again through the whole scheduling cycle. And how could you achieve that if you kept the pod there? You would have to like resubmit it again to actually go through the scheduling cycle.
Yeah, so I think you're talking about restoring to a different node, right? I mean, just to kind of like brainstorm here, like I think one way it could work is we could say, okay, you're allowed to make, basically we say node name is now a mutable field in certain circumstances. Maybe we say you have to, if a pod's in a suspended state, you can change the node name, and then it gets, moved over to a new node, and you can then resume on that node.
Yeah, actually, this moving operation is quite complex because it depends where and how the snapshot checkpoint is stored. So yeah, we have to talk about this. Essentially, have to figure out if we can actually change the node. But I guess we have to treat in place checkpoint restore as one use case, and then where we use suspend resume, and then the checkpoint restore operation where we can restore on different nodes as separate for now. And later on, we can see if they could be combined somehow.
Yeah, in the document that I listed, linked farther down in the agenda, I had a bunch of questions around like things around identity and devices that I think come up when we talk about moving nodes. I think resuming on a different node is not really a simpler problem than restoring a pod on a different node. And so yeah, my suggestion was specifically around like focusing on the like in place suspend resume, not moving nodes, and then kind of solving these other problems later.
Yeah, makes sense.
Yeah, because just a quick comment on that, like one of the ways we kind of worked around that node movement piece was that we essentially had a scheduler plugin that, knew about where the checkpoint restore image ended up or where we wanted it to move. And then we tricked the pod to get rescheduled and then resume on that same node. So.
Yeah, and I see that we are over time. I just want to summarize as next step. I guess I'll go through all the comments and essentially this document and the meeting notes. But I guess as next step, we can go to SIG API machinery and discuss with them whether it would make sense. This would to introduce the checkpoint restore sub resources for the pod. Peter, do you have any comments, questions before we end the meeting?
Nope.
Okay, cool. Thank you, everyone.
Thank you.
Thank you. Bye-bye.
Bye-bye.